Okay, welcome to this industry session, which is a long-standing tradition of QCrypt. I see a few industry guys in the room. Some are still coming on here. So let me also introduce myself. So I'm Nicolas Gisin from the University of Geneva. And to be transparent, for those who wouldn't know it, I'm also a founding member of IDQ and presently the chairman of IDQ. So after my very short introduction, we'll have presentations and then a panel with the people you see here. I will introduce them in due time. But let me maybe just start with my short introduction. Some of you may remember that 3 years ago, there was a QCrypt in Japan, so still in Asia. And there I was giving a plenary talk. And let me just show you the first slide I used. It's exactly the same as the first slide I used 3 years ago, except that I added the label QCrypt2018. And I want to draw your attention especially to the second point here, that one. So I made the statement at this time that in 10 years, EVA QKD will have found its market or will be dead. I think this is a statement to which I still hold, with, of course, the difference is that we only have 7 years to go now. I have asked all the panelists to address this statement and tell us what they think about it and whether we are on track or whether there's a danger. And when I speak about the danger here of failing to meet that kind of deadline, I don't think it's a danger just for the industry. I think this entire conference would collapse. Now, my personal opinion is that in these last 3 years, we made really very significant progress, and I'm quite optimistic that we're going to make it. We've seen during this QCrypt conference all what is going on in China, and we'll hear a bit more about that. But there's also a lot going on outside China, and we certainly also hear a bit about that. And somehow it is quite very good reasons to be optimistic. One reason to be optimistic is shown on my very last slide here. So this is a slide. Of course, you see it's a bit biased, the choice of the slide, but anyway. So what is interesting here on is that you see that on this card, you have on the top right 12 little chips. And actually, each of these chips is a quantum random number generator of the size indicated, 3 times 5 times 1 millimeter. And in the chip, you have the light source and the detectors. And so it is really the same kind of quantum random number generator as I also presented last year at QCrypt in Cambridge, but much smaller. Actually, I'm not exactly sure what is the ultimate limit, because at the end of the day, you need an LED and a few detectors. And probably you could put that even in a smaller package. But anyway, having 12 of them on a small board, or one of them in one of these USB stick, is, I think, very impressive. It's not impressive in terms of science. This is pretty trivial science. But in terms of technology, I find that very impressive. OK, without any further ado, let me start. So we have today the great honor. We go back to the first slide. We have the honor of having Dr. I have to go back to the beginning. Yeah. Yang Zhao, who is the CEO of Quantum CTech. We've heard already of Quantum CTech here. This is the largest Chinese QKD manufacturer. And Mr. Zhao is also chair of the Quantum Information Association in China and Deputy Director of Research Center for Quantum Technology and Applications of China Academy of Sciences. So it's a person with many hats. And maybe just very briefly, he did his PhD in Germany about almost 10 years ago. And then straight after that, joined Quantum CTech. So let us start with Mr. Zhao, who, please.
Very nice introduction. So I suppose I'll be okay. Good afternoon, everyone. And I would like to share the integration of quantum key distribution technology with what? With the infrastructure. So we want to do integration with the networks. Also, we have to going to do the interaction with the application. We have to do the service integration. So I would like to show you a small video, only 2.5 minutes.
Quantum information is a description of the microscopic physical world. According to the quantum superposition and uncertainty principle, information encoded in quantum states cannot be precisely measured or cloned. This makes quantum state a natural separated information carrier. Today, people can transmit quantum information between distant nodes with quantum communication technology, which is developing rapidly in recent years. Breakthroughs in the wavelength division multiplexing technology allow quantum and classical signals to independently propagate in a single fiber. This greatly facilitates the integration of quantum and classical communication infrastructures. With these technologies, China has built a practical quantum key distribution network with a considerable scale. Quantum key distribution network is an infrastructure that provides key resources for various applications. Furthermore, an open application enablement platform can be established to provide end users with quantum secure communication services. The open application enablement platform is driven by a universally adaptable engine, which is independent from operating systems, services, or application scenarios. The application can be a cloud service, a government enterprise private network, a mobile communication, an Internet of Things, an Internet of Vehicles, or artificial intelligence. Based on the application enablement platform, every developer can build user-oriented applications, shielded with quantum secure network, which services with quantum security.
Thank you. As a manufacturer, we are thinking about how to make the QKD products grow, and we have to think about how to provide a service, how to get more and more, players to work together to make the market big. So I have to think about, so we do the quantum key distribution technology. We worked with the telecom carrier to build a huge networks to provide the key to everyone. And then you have the key, what to do with the key. We have to think about how to use the key to make applications. So on the project, we worked with a lot of companies, for example, China Telecom, China Unicom, to work together to see how we can achieve to combine the quantum signal and the classical communication. We get a lot of progress. For example, in the city of Wuhan, we have built new metropolitan networks. Almost all the links, we are using the light fibers. And also from last year, we transmit the quantum signal with 8 terabits per second conditional communication over 100 kilometers in the lab. And also in the field test, we finished 3.6 terabits per second traditional communication with the QKD together over 66 kilometers. So we try to push combine the quantum signal and the conditional classical communication together. And also, we have the concept how to make the service very handle. So we treat the quantum key as a resource. QKD is the resource of the keys, but the quantum numbers. And then we, with the help of the networks, we build a huge networks to distribute this resource. And then we have the application enablement platform, or called Universal Adapt Engine, to provide the keys to a lot of services. For example, we can work the keys with the Internet of Things and intelligent manufacturing, artificial intelligence, blockchains, big data, smart city, cloud service, and even the next generation mobile communication technology. We think we can use the keys to provide a service, to provide secure service to all kind of ICT technologies. So our vision is to make all these kind of ICT products, services secured by the quantum key distribution. Thank you. That is all my presentation. Thank you.
Thank you very much. So we move to the second presentation by Grégoire Bordy. So we are very fortunate to have also the CEO of the largest QKD company outside China. So Grégoire didn't send me his CV, but it so happens that I know it, more or less. For instance, he did his PhD in Geneva. Once he finished his PhD, we started discussing with an American company, Magic Tech, about possibly transferring our QKD know-how and technology. And at that time, interestingly, Norbert Lütgenhaus, well known and sitting in the audience, was working for Magic Q, and so he was sent by Magic Q to Geneva to negotiate with me and my colleagues how to do this transfer. And so we discussed and so on and didn't agree and blah, blah, blah. And at some point one morning, Grégoire came to me and said, you know, actually, I want to do that. And okay, I was quite surprised. He was a good student, and I didn't really expect him to be doing that. But actually, then he told me, and you know, in secrecy, I did also an MBA. I didn't tell you because I didn't want my PhD advisor to be annoyed that I don't spend all my time on physics. So I did the MBA behind the door, let's say. And but I'm ready to go for a company doing a QKD company. And so here he is. And well, thank you for being with us, Grégoire.
Thank you, Nicolas. Good afternoon, everybody. It's a pleasure to be here. And I would like to tell you a little bit about ID Quantique and maybe the development of the past 3 years, because Nicolas mentioned this 10-year deadline. And I'd like to tell you about what's new without going into too much details on the products. And so maybe just to give you an overview, as Nicolas said, IDQ was founded in 2001. We were 4 physicists or four scientists from the University of Geneva. And we started as a small company, no venture funding at the time. And so we had to find ways to generate revenues. We did that by starting with detectors and scientific products, which is still one of our activities. And then gradually invested what we could generate into quantum random number generator and QKD. And then eventually we're able to raise some funds and grow the company. And so right now we're about 80 people globally. Half of them are engineers and physicists. We have, I insist, it's not only physicists. Engineers are very important in a QKD company. And the main location is Geneva, but we've just opened offices in Bristol in the UK for a project with BT and some Innovate UK projects. We're also opening in the US and in Korea. And we have a joint venture company in China, in Hangzhou. Currently we're active in 2 fields, the scientific products and solutions around single photon detectors. We call that quantum sensing, and most of you in this room will say, oh, this is not really quantum sensing. But outside of this room, this is calling this quantum sensing is okay, and it makes it a bit more sexy. So this is what we call our quantum sensing business unit. And then we also do quantum safe security, which is products around securing data in a quantum era. So one important development that I'd like to mention now is that we received a fairly large investment earlier this year by SK Telecom. SK Telecom is the main telecom operator in Korea. And they had been operating a quantum technology lab for 6-7 years in their research office. And this year, they decided to invest in ID Quantique with the view to take quantum key distribution technology and quantum RNG to the next level and to develop new applications. This is a fairly large investment, 20 million Swiss francs, which is approximately $20 million. And what's important also is that in this investment, they kept the trust in the current management team and the founders. Nicolas and I are still on the board of directors, so there's continuity there, and the management team has not been changed. We've had some additions from our Korean colleagues, but no real change. The patents and the quantum technology lab of SK Telecom will be spun out of SK Telecom and will be integrated into ID Quantique in order to have more bandwidth. So that's an important development because it's a key player known in the telecom world as a very early adopter of new technologies, which is saying we want to make a bet and push quantum key distribution and other quantum technologies into the market. So, So in terms of our activity in quantum safe security, we have basically three components. The QRNG, I'll say a bit more about this later, quantum key distribution, but then also, similar to what Mr. Zhao mentioned, bundling this into solutions, because what customers really want, they don't really care about keys. What they want is an application that uses a key. And this is an important part of our business to develop full applications and enable them to use keys to secure something. And it's important to go all the way to the applications. Now, in terms of QRNG, we had our old products. You see them on the left, relatively big, but on the market since 2004, very reliable, certified, and everything. And a recent development is this new chip developed in collaboration with SK Telecom in order to address new applications where size and price matters. And we believe that this will open up many more applications for QRNG technology. You see that the size of this generator is about 5 micron by 5 micron. It complies with all the global standards, including NIST standards. Performance is 1.5 megabits per second, so it's not particularly fast, but it's small and cheap. And an important thing here is that it involves a collaboration between 3 types of actors. There was the University of Geneva at the origin of the ID, the group of Hugo and Nicolas. Then IDQ took it for the first level to try to work on a business case, but we needed more resources to go into chip integration, and the integration was done by SK Telecom. And now this is all coming back to ID Quantique for commercialization. So that's an illustration that there's a value chain, and different actors must work together in order to succeed in this new quantum innovation. Now, why did SKT invest in IDQ? Well, for SKT, there are 2 important buzzwords. We saw quite a few buzzwords earlier, but there are 2 important ones for a telecom operator nowadays. It's 5G and it's IoT. And 5G is not just more bandwidth, it's actually more bandwidth, but also with better quality, lower latency, and this kind of services. And the idea is that with 5G, you can connect then the physical world, the connected cars, the IoT, the smart grids, you can connect them through 5G. And the vision of SKT is that they're going to deploy 5G, they're world leaders, they want to do it first, but 5G has to be secure because a hack on 5G will mean people potentially dying. Not only data loss, but potential car accidents or smart grid problems and things like this. And so the vision of SKT is that QKD can form the physical layer security for 5G networks. And this is going to happen in less than 7 years. And so my answer to Nicolas' question is that we're on track and we're making progress. One challenge that we have now in this progress is to find good people. And so if you want to be a quantum mechanic, please talk to us. Finding people that understand the physics and the engineering is a big challenge. And there was an article earlier in August in Wired magazine talking about the fact that quantum computing, quantum technologies in general, is a developing sector, but right now it's blocked by the lack of people. Basically, we have to take normal engineers and train them in quantum, which takes time, so it's not so easy. So if you're interested, please go on our website or please send us your CV. And so finally, just a last word to say that if you're interested in more practical things about quantum safe security, please check out our winter school. We've been organizing it for 10 years. The 11th winter school will take place in January of next year. And we always have great speakers and very good discussions, as well as state-of-the-art information on QKD and applications. Thank you for your attention.
Thank you very much, Grégoire. We move now to the next speaker of this panel, which is Dr. Momchil Piv, who is from the Chinese company Huawei, but actually Huawei Germany. I know Momchil, I don't know, for many years. Just to see here that he was actually born in Bulgaria and studied in Sofia, so the capital of Bulgaria. And that by training, he's a mathematical physicist, but then also by joining the AIT company in Vienna, Austria, became more a kind of liaison between, let's say, mathematical physics and applied physics, and in particular, QKD. So, welcome, Momchil.
Okay, so I decided in the first slides to take one step back and see why the hell we really need QKD. Actually, not we, I mean the world. And actually, it's all about communication security. And, you know, today, wiretapping of unencrypted communications is ubiquitous. Whatever you send, you'll be sure it will be read somewhere. This is an example just that is a kind of a submarine of world power that wiretaps the submarine cables all over the world. Yeah. Not only this submarine, there's a fleet of that. Okay, so in some sense, it has become increasingly clear that secure communication is a must. So we should at least encrypt. But what after that? You know, something of this sort could be coming, yeah, which is a kind of a very early prototype of some quantum computer. Okay, so what to do? Why QKD is an advantage in this respect, and how to go for QKD. Okay, encrypt, but public cryptography-based key distribution based on computational complexity will be gone now or later, but at some time it will be gone. And actually encrypted data stored now will be decrypted later, and data are stored now. So in this sense, you can be sure that this is what is now is not long-term secure. Post-quantum cryptography, all QKD are needed, and actually what is the case for QKD specifically? It can generate another layer of physical security, which is different from the mathematical security, whatever it is, of post-quantum, so it could be an advantage. So in this sense, the market, just to answer Nicolas, implicitly exists and implicitly needs QKD. It just has to learn it. And, and actually the QKD and the QKD community definitely need the market. I completely agree with that, because the ubiquitous public donations which exist today also will finish at some point of time, different points of geography, but they will finish. Okay, and so how to bring the QKD beyond the niche domains where it actually exists today? And yeah, I think the recipe is what is my suggestion, but I think it's pretty universal. First of all, identify true use case domains, yeah. Not only fancy ones, but really true use case domains. And then understand what potential users really need, yeah, because you don't need, I mean, these very fancy and nice diagrams, loss versus rate, that's nice, that's for us, but not for them. And adapt to their needs. And when you do, then provide products that are easy to use, adapted to existing infrastructures, you cannot afford new infrastructures, relatively cheap, and of course certified. So this is a recipe. If we can manage to follow it, I think there is a good future for all of us, yeah. It is a branch of Huawei Research, which is situated in Germany. There is also some research in that direction in the headquarters in Shenzhen. And it is pretty young, founded in 2015. And actually our target is to develop the quantum communication technology to an industrial scale of readiness, of course, in conjunction with the Huawei communication technology, which is pretty advanced, as many of you know. Of course, not of course, but you should know that our group needs to focus on research and development and cooperation efforts in Europe alone, because there are very stringent export control laws, and even Huawei, we cannot come, for example, to China without further, let's say, licensing, which is at present not available. We want to participate, and actually do participate, in major European activities as a flagship. We have really been part of one such project. And the Huawei at large, the big company, is to decide on the potential economic application of QQD depending on the overall market assessment and technological readiness, which is expected to take place relatively soon. Good. Actually, what we have done up to now, it's 3 years, but as I talked to Gregoire a few minutes ago, 1 year and more, it was just collecting the lab, equipment, people, and our real work started maybe 2017. And actually, we have developed a CVQKD prototype. So our technology is continuous variable QKD, so sort of untraditional in the present industrial landscape. Okay, our prototypes are software controlled, robust, flexible, and they're adapted for the SDN, which is software-defined networks. They're potentially cheap. One transmitter can switch between many receivers. In our case, we have currently 2, but there is no limitation in that respect. It is integrated, and it makes it a bit different from all other existing stuff with standard Huawei Metro OTN devices. In our case, this is the so-called OSN 1800. Some people from communication technology would know it. And it can, in principle, potentially co-propagate with 17 classical wavelengths. And at the moment, we have implemented 100G encrypted wavelengths. And the encryptor is also on board of this OTN. It operates in a typical metro environment. We have done a recent experiment, let's say demonstration in Madrid, which continued from the end of May and the end of August, and it was a completely flawless operation for several months. Okay, our system in the end tolerates 12 dB per link at the moment. 16 dB will be the target this year, and it is compatible with key duration of something like 50 kilobits per second at this 12 dB. Okay, so a few photos. So these are our prototypes. This is the network. This is Ignacio Sirac. Many people would know him. He happens to be now a member of the board of directors of Telefonica, and he's presenting the devices to the assembly of shareholders of the company, which was a big fuss somewhere in June. And there was also a press release and all that. So summarizing, we have tried something new. It is really flexible, software-defined, adapted to SDN, which is one main target of telecommunication companies. So it is, and we look very carefully to their needs. Future European projects also target on that. We have, let's say, on board several big telecom companies, and would derive requirements that will be then transferred to specifications of products. Okay, thank you very much.
Okay, thank you very much. So after the two CEOs of the two largest QKD companies, and now we had a representative of one of the huge Chinese company, Huawei. We have a representative of another huge Chinese company, Alibaba, who is represented by Dr. Chongjing Shi. And since I didn't get a CV, you're going to introduce yourself, I'm afraid. Thank you very much for being here.
I don't have that. Please excuse me, I don't have any slides. And thank you, Professor Gising, for a nice for introduction. I knew him quite a long time ago. He probably didn't know me. And I graduated from Beijing University in Post and Telecommunications in 1999. Then I went to Chalmers University Technology for postdoc, and there I met you. You gave a talk over there on population mode dispersion. I was working on that. So that's first time I knew Professor Gissin. Second time is that ECOG 2000. Professor Gissin gave a tutorial on quantum communication. That's the first time I know that quantum communication. And in 2001, I joined Bell Labs in US. I'm working on optical communications. And 2014, I joined Alibaba in charge of basic data center optical technology. So as quantum communication, it's kind of optical communication. It's use photons, use fibers. So it's in my group. We have a small group working on that. We started quite a long time ago. I think Alibaba was the first company, internet company, tried to use quantum communication to protect our data. So we started 2014, and we collaborated with Quantum CTEC, and trying to understand this technology and trying to explore the opportunity using quantum to secure our data. So we started 2014, and then 15 we built a test bed in Hangzhou, and also we participated in the Chinese long distance quantum from quantum communication link from Shanghai to Beijing, and we are one of the users. And it's so after so many years, not so many years compared to the guys sitting here, we are still quite new. And what are we doing? So first thing, probably people ask why are you doing this. So it's very simple. It's Alibaba. I think we are the world number 3 cloud computing company. For cloud computing, basically people put data in your network, in your system, and the first question they have is that how can I be sure my data is secure? So we explore various technologies, and quantum communication is one of the technologies we're exploring. And so we need to give our users highest confidence that the data on our network is secure. So that's why we started this. So what are we doing? Probably I want to. We are not making a quantum key distribution equipment. And what we are doing is that we wanted to combine the QKD or other quantum security technology with our cloud computing platform. So you can think about we are a cloud computing provider. We don't make any servers. We use the servers, provide cloud computing. So basically we don't do QKD equipment. We combine the QKD with our cloud platform. So we wanted to just to make this quantum technology available to everyone. And according to your need, according to your probably security level, we can dynamically or elastically provide keys or manage keys for you. So I think one of the big things for QKD is that people think it's quite expensive. When we want to use it, I need to have a separate independent system. For us, is that all systems are shared. We just allocate resources to you to where you need. So that's one of the things we are doing right now. So in this way, we really need various talents. We not only need physicists who understand quantum well, so we really need someone to understand the physics behind this. Then we also need software engineers. So for quantum, for cloud platform, most things that software really have ideas and need software to realize that. So that's we need both quantum physics guys who deeply understand this technology, so you know and how the behavior, what kind of service can provide our customers. Then we need software engineering to make it reality. So that's what we're doing right now. Okay, thank you.
Thank you very much. So we move to the last presentation of this well, introduction to the panel by Dr. Xiang Zhao. I hope I pronounce all the Chinese names more or less correctly. So he did his bachelor from Wuhan University and then joined CEPRI for a master and PhD thesis. So CEPRI stands for Electric Power Research Institute China. And so now he is a kind of telecom and information engineer. So that's, I don't see quantum here in, but there will be certainly some connection. And one thing I also learned is that Xiang likes to run, and he writes that each time when he goes to a conference like here, he takes, of course, the laptop and his running shoes.
Thank you, Professor Jisung, and thank you for the organizer to give me such a chance to introduce our work on the quantum cryptography technology. And you know, I am from Secret Information and the Telecommunication branch. And we are not only the user for this technology, but the developer. So today I will introduce application and research of quantum cryptography technology in power industry. And the power industry is a public service industry. This is a typical structure of power industry, including generation and transmission, transportation, and the dispatching, and the distribution, and the user. Every aspect involved in security issues. This is not only because of the operation security, but also because of data and the privacy for the end users. Quantum cryptography can improve the information security level for the power grid. But there is some difference for the application for the quantum cryptography in power system. This is mainly because the communication fiber media. You know, there are two mainly fiber cables used in power system. These two cable, OPGW and OPPC. OPGW is a kind of fiber communication cable. It is the name of optical fiber composite ground wire. And OPPC is the optical fiber composite phase conductor. These two kind of cable is not only communication cable, but also the electric circuit. And this is a picture taken by one of my workmates in Xizang province, Chengdu, just 7 days ago. It is Xizang Power System Interconnection Project. Some of the tower are built on the mountain with the altitude 5,103 meters high, with very bad working condition. And all the communication cable fibers are installed and fixed on the top of iron tower in power system. So the iron tower and the heavy wind caused mechanical stress and the vibration and the waving. And it will change photon polarization state. And it will also affect the quantum cryptography transmission performance. So if we want to apply this technology in power system, many adaptive work should be done to improve the performance. And there are two projects we are now doing to improve the performance. The first is research on the technology of quantum key anti-interference transmission in power system. And this project is mainly concerned with the electric power fiber cable its influence on the photon polarization state. And it is from Beijing Science and Technology Commission project. The second project is research on the engineering technology in application of quantum cryptography in power system. And this project is mainly concerned on the long distance and the reliable QKD system. And the power system, the power station in power system is often very long, between two stations, sometimes 100 kilometers, and even to 200 kilometers. And so the current situation, the current technology cannot reach such a long distance. So we have to do some adaptive work to improve the transmission performance. And this project is from the state-grade project. And this is the devices that were developed for the rapid feedback polarization control system. And these devices were developed together with Mr. Zhao Yun's team. Besides, we established quantum cryptography work group based on the QCrypt D2. QCrypt is the international academic organization. And we established a work group just mainly focus on the following research field, such as various QKD technology and QKD system for power system, and network management, QKD standards, power system application strategy, and worldwide QKD applications for power system, overseas business, and integration technology with energy internet, and the security evaluation and the testing technology. And also, we built a QKD standard hierarchy, and two of the standards have already been finished, and one is undergoing. There are 8 standards. And this is the picture that we built, three demonstration projects together with Mr. Zhao's team. The first is quantum cryptography communication network for urban area of Beijing. It's just for power system. And the second one is worldwide quantum cryptography communication network based on the Beijing-Shanghai trunk line. And the first project is built within Beijing city. And the second one based on the national Beijing to Shanghai trunk line. We connected Jinan node and the Hefei node and Shanghai node into the national trunk line. And the second project is under construction. And we built based on the experimental satellite, and we realized the worldwide, the wide range quantum cryptography and by the quantum satellite. And this is the picture, the service application verification. And there are 2 parts. The first part is based on Beijing urban network. It's mainly for power system operation services. And the other is mainly for the enterprise management information system. And this is one of the application sample we used in Qingdao this year in June during the Shanghai Organization conference, cooperation conference in Qingdao. And we use our self-construction quantum cryptography network, and together with national Beijing to Shanghai quantum cryptography network. And we delivered from Beijing to Jinan and then to Qingdao. In Qingdao, we encrypted the information date to satellite and then to Shandong and then to Beijing. And this is my speech. Thank you.
Okay, thank you very much. So this was the last presentation. So now I invite all the panelists to join me on stage. Please come on. And so we have time for quite some time for questions and discussions. So I guess there are people with some microphones in the audience. So who would like to start with a question? So maybe I'll start with a very easy question, because I told you in advance which is the question, and I think only Grégoire was very explicit about that. So do you think we'll make it on time to the market for this field to be successful, or in 7 years we are dead? And why? So who would like to start on that one? Of course, you're all going to be positive because you are paid for that, but try to argue. Yeah, Momche.
Let me start. So I'm not completely sure that we'll make it on time, because it really very much depends on psychological factors. But it appears that now there is a momentum with huge, let's say, companies to adopt QKD. And if this momentum continues, I think the initial study phase, what it is all about, will finish like something like 3 years. And then we would still have some time. Of course, we need a coincidence of many factors. It could happen that technology will go down in history as many others.
Okay, so you're saying there is, okay, Huawei that you're representing, Alibaba, okay, let's say SK Telecom in the middle between you, and many more of these huge companies, but you put some kind of middle milestone. In 3 years, the study phases should be gone and a large market should open.
I mean, I think this is the 3 years is the period for which the real end users would have to find out whether and how they need it. Because at the moment, they want something, it is pretty nebulous. And actually, this has to be boiled down to more concrete things. Yeah. So the two levels, the technological level, engineers are much more near to what it could be, but of course, management is an unpredictable factor.
Okay, maybe Quantum C-Tech, what is your view?
I think we are more positive a little bit. So we already work on that more than 9 years, and I think ITQ is spend even more time on this. We think we can. I think it's quite good time for us to push on QKD technologies. I think I have to focus on the emphasis we have to do with the market, not only the manufacturer or the technologies owners to only push the new record. We work with the market actually together to find a way how the QKD can be accepted by the market, how it can work. But generally we are more and more convinced and confident. So I think, including the quantum number generator, so we build the bigger concept of the quantum safe, quantum security. So not only certain technology to serve the customers, we build more bigger concept, serve more people.
Thank you very much for these comments. So, yes, there is one question coming from the Russian Quantum Center, the Russian friends.
Yeah. How do you think, what technological change should happen so that QKD and like quantum communications become not exotic technology like fiber-based communications were like decades ago, but it will become a common technology for middle-sized business, or maybe even for end users for households.
Thank you. Good question. Who has an answer? Grégoire.
So I think one of the important changes is integration in applications and current transmission systems. Because right now it's too complicated, it takes too much time to do, if you can deploy QKD, but then how do you feed the key into an application and use them? And so we see, I agree with Momchil, we see a lot of interest from large enterprises. This has changed about a year or 18 months ago. Not so sure why, but there's clear traction, interest. But then, so it's easy to do a proof of concept, but then the question is, okay, now I have this communication network. If I wanted to go to the next level, how do I integrate into the application? So it's boring engineering. It's not so much quantum stuff, but it's about defining standards, doing the integration, providing the management systems, providing the key management systems, and all of this. This is an important development. Maybe if I may just add a comment on your earlier question, Nicolas. So you're talking about this 7 years, there's this 3-year milestone that Momchil mentioned. I think we'll have also an intermediary milestone, which will be the time when the NIST competition, or NIST, they don't call it a competition, but I think, what is it? The NIST process to select post-quantum cryptography, when it will reach, when it will come to an end, in a sense, we will need to have made significant progress toward QKD certification. Otherwise, there'll be a strong imbalance between the two technological choices for quantum safe. And here, I'm not saying that one excludes the other. Really, I think that's very important, is that they have to work together. But unfortunately, they have to be seen on the par in terms of maturity if they are to be integrated together in a quantum safe crypto infrastructure.
Yeah, thank you very much. I guess another part of the answer is also to make it cheaper. That has already been mentioned, but I think cheaper and also smaller. I think the example of this quantum random number generator, which started like a big box and is now a very small chip, essentially there's no reason that QKD cannot also become extremely small. Maybe not as small as the quantum random number generator, but certainly much smaller and cheaper than it is today. But maybe we can also have an answer to this question by one of the users, either Alibaba or Sepri. I don't know which one. What is needed for you to massively buy QKD?
I agree with some of your comments. First thing is that it's ease of use. There are two things for ease of use. So first thing is that you can easily integrate your QKD into your system. And right now, QKD is kind of from some providers who really don't know quite about your network, about your system. It takes quite a long time to put it in your system and integrate in your system. So these things, so I think this industry have to work together. For example, Huawei it's a network company, you have lots of experience. If you join to this industry, I think makes things easier because you understand network, you understand the quantum QKD system. And second is that it's ease of use, is the cost. And I think not only just the QKD system itself, then the big thing is that the fiber, you need to have separate fibers. And lots of service providers coming like us, you only have fiber. And for QKD, you need to put a separate fiber for your system. If you can put your QKD channel together with your data channel, it makes things much easier. And then another thing is that right now it's distance limited. And you may not be able to, if you put it in your system, it's about tens of kilometers. You go to 100 kilometers, it's difficult, and need to put regenerators and make things complicated. I think these are two big things to prevent from wide deployment.
Yeah, thank you very much. I understand all that. Very good. Maybe you want to add something, or maybe the next question? Okay, please. You want to add something or not?
Stage grade, the requirement. For the power system, it's very important basic infrastructure, and many threatens if the security is not very safe, and the power system will have very serious problems caused by the information security. It is because of the operation of power system, and also because of the user state, and users' privacies. So QKD is very suitable for the power system security construction. But there are still some challenges and problems for the QKD's improvement. For this technology, and the current technology can just transmit only just 50 kilometers. But the power station distance reaches 100, and some of the distance reaches 200 kilometers. And the most important affluence is that the electric power fiber cable are fixed on iron tower, not in the channel. So it will cause great influence for the QKD system. So we still have many work to do.
So you're talking about this distance. Today it's more like between 50 and 100 kilometers. 200 kilometers is clearly technologically feasible with today's technology. We had nice talks here today about that, or yesterday. But this is some way to go. You also mentioned the multiplexing in wavelength for the quantum and classical multiplexing. That can also be done. But again, it's a challenge, but this is interesting challenges. And you also mentioned the aerial fibers in which polarization is fluctuating. So polarization-based systems are limited. And then you better go to time bins or over encoding or continuous variables maybe, or something which will be polarization insensitive. Okay, so, and Grégoire, he mentions more the certification and standardization, which is a very different issue. But so we see we have all these issues. Some are, let's say, still about physics. Standardization is no longer physics at all. Integration, making it cheaper is also not physics. But yeah, we have so still challenges on all sides, which is good. There is future for our community. Gilles, please.
Yes, thank you. I would like to react to sorry, to what Grégoire said, and in fact come back to your main question. 3 years ago in Tokyo, I was in total agreement with you that it was 10 years or die. I'm less in agreement now. No, let me explain why. Because in the meantime, in these past 3 years, there's been a really serious awakening of the classical community that they're in big trouble because of quantum computers coming. So there's a NIST thing, but it's not just that. There is a very, very serious push at the moment to get rid of RSA and all this obsolete cryptography and replace it by something else. And if that something else does not include QKD, we may not be dead, but we're in big trouble. And that will be in less than 7 years. So again, there's the NIST push, but it's much bigger than that. So whenever RSA goes down, if it's only replaced by classical post-quantum crypto, we'll be in trouble. And that's coming soon.
Yeah, I think that's a very interesting comment, and it also goes back to one thing that Grégoire said. So RSA is dead. I actually announced it also 3 years ago in Tokyo. It will be replaced, and I think there's just no way to avoid post-quantum crypto because it's very practical and there will be many applications for it. So I don't think we should see that as our enemy. It should be our partner.
Absolutely.
And there will be different markets for post-quantum. and quantum crypto, then of course it's a matter of the size, and we should certainly, as Gregor said, a bit work together. There's also, and actually this is a country where we should ask this kind of question, it's very clear that the US and China have different policies in many fields, including here. And it's very well possible that the two technologies will be developed and deployed differently in different countries. So we don't know yet, of course, but I think this is certainly a possibility. There's no reason, I mean, RSA was kind of worldwide dominating everything. Possibly the next dominating technology will be different in different of these big powers. What do you think about that? Does that make sense? Alibaba, global player, is hesitating.
Well, in the meantime, I totally agree that it's not a matter of post-quantum or QKD. They should work together towards a common goal and be integrated.
Yeah. Okay, maybe, yeah? Yang?
My question is, how do you convince your customers that your QKD networks is secure as you announced?
So I guess this is a question to both IDQ and Quantum CTech. How do you convince your customers?
So I think we're already working together to doing that. So we get together to build the standards, to evaluate how the system is working as your promise, like a quantum key distribution should work. And we have a lot of physicists and we have a lot of the scientists to work on to improve the new protocols and the QKD protocols, secure or not. So actually, we are working together to generate, just like ETSI, ISO, and ITU. So we built the international standards to convince ourselves and also convince the customers their products working well, like what we promised.
Mm-hmm. So yeah, so you also emphasize the need for standardization. And so, probably everybody here already knows that ETSI is working on that since years, but there are now also activities starting in different bodies like the ITU and some more. And clearly that's a place where we are going to work together or all together. Yeah, Grégoire?
And so this is the right answer, but unfortunately it's the answer for the future because we don't have these standards yet and this certification. So right now we have to rely on other means, which are trust and explanations and demonstrations and keeping the classical crypto and not replacing it, but putting it in parallel so that in the worst case, you can always fall back to the security you had before putting QKD. And so I think this is a very important point, is that some of the market development is slowed down by the fact that it's not so easy to convince customers. And one big impact of standardization and certification will be to enable more customers to make a decision more quickly.
We can see the progress is speeding up, right?
Okay, we have also a question here. I just want to make some, I'm adding some comments on the saying that the post-quantum and the quantum key distribution. Yeah, I think I totally agree with you that we work together. And also in China, there is a society working on the post-quantum. And I think we have some, for example, for the future plan, for the flagship money, there should be some research on the post-quantum. And we have, maybe you know, there is a famous cracker, a mathematician called Xiaoyun Wang. She did some hash function for MD5 and SHA-1, and now Google make it practical, and she's also working on that. So, but in one side, she cracked the classical cryptography. So in that sense, we don't know whether post-quantum is still secure against the classical kind of algorithm. We don't know. But meanwhile, there is also a lot of cryptographer, including Xiaoyun. She's also working on the post-quantum, and Jing Taiding, maybe you know. But unfortunately, she couldn't come. But yeah, Hongxiang, they're also working on that. So I think we work together. Okay.
Maybe I can ask you, in this Chinese flagship that should start soon, do you have actually money for standardization?
There should be, but I don't know. I'm not the people who is in charge of that, but I think there should be. I think there is some. I think there is some 11. Oh, I forgot the exact number. The person they makes. I mean, of course, not me, but I think there should be some standardization money. Of course, yeah. Okay. It's very important. Yeah, just like the people say, why we trust you, but it's just like government provide that. I don't know why you trust them. But.
Exactly. By the way, ETSI, the E stands for Europe, but the next meeting will be held in November in Beijing, because it's really an international body. So let's move to the, I see someone, it will take place in Beijing. Isn't that correct, Norbert?
There are two different things. That's one is the standard certification activity, where the next meeting will be in Madrid in December. And then there's the ETSI IQC workshop, which brings together industry and academia, which indeed will take place in Beijing. But this one is not doing the standards and certification.
Okay, if you want more information, go to Norbert, who is, I don't know, maybe vice something, and Andrew Shield, who is maybe also in the audience, is the president of that group, isn't it? Is that correct? Good. We still have time. I don't see, someone is pointing. Yeah, okay, sure, good. Go ahead, please.
Okay, hello. My question is, from what I know, up to date, most QKD experiments, at least long-term experiments, are on country levels. So, well, I don't count European Union because it's essentially a tight union of countries. So, and
I wish you were right.
Okay, so my question is, so will we see a truly global quantum network like the internet, which would involve European Union and China and possibly the United States, Russia, and like all the countries where currently the quantum, well, essentially quantum internet is developed, and what it takes to achieve that? Because, and like the question connected to that, what should we do first? Should we focus on government agreements, or on standardization first, or, across the links across the border? So what comes first? And also, how do we deal with the problem that if we take, for instance, the trusted node technology, okay, you can trust the trusted nodes on your country's territory, but how do you trust the trusted nodes on another country's territory? So, well, I understand that it's a complex question, which is hard to answer like in brief, but what's your view on this truly global quantum network? Thank you.
Okay, thank you for this question. So who would like to address that one?
Maybe I'll start, but so first of all, I'd like to say that we have customers on both sides of the borders, with data centers on two sides of a border. So there's already, in a sense, an international quantum network, but it's still limited to private networks. And so I think the first step for the development of applications of QKD will be private networks for organizations. And so in that respect, I see less need for large-scale global networks. But I think that will be the first step where we start to get volume. My view is that a global network will be more long-term down the road. There's the challenge of crossing oceans, because we may be comfortable to put trusted node on the ground and QKD equipment. Putting them under the Atlantic or another ocean might be a bit more risky. So we need maybe satellite technology. So I think there's quite a bit of technological development before we can start to think concretely about global networks. And again, the first applications will be on the regional or country level.
But I think that's clear. Okay, it's pretty clear that actually the first global initiatives would be on the standardization level. I mean, that's clear, because we cannot expect anything before more or less widely adopted standards are available. So I would expect that the first initiatives on an international, truly international level, Europe, China, United States, could be only related to standards.
So I think the global network, global quantum networks is definitely our goal to achieve. So I think we already, the society, the QKD society already equipped that kind of technologies, the fiber links, trust node, maybe 10 years later, the quantum repeater, and also today we already have achieved satellite ground connection. So across the ocean, I think, just like you mentioned, we can use the satellite, but on the lands, so we try to push, especially some issues we have to address, not only from the technology level, and also from the different policy of the different country. So, and also we have to think about why we need this global interaction, the QKD interaction, to protect what kind of service. I think also for the nowadays we are pushing, trust in node the technology to be, security improved, or so we can work on a lot of engineer, protocols, not from the physical side. From physical side, we have to work on the quantum repeater. So I think should be good, very good. Our dream to realize a global network. So but we have to figure out what it work for on the global interactions and the global service.
Yes, thank you very much. We have still time for a few questions. Maybe here, please.
Just besides the engineering, so from the industry point of view, what do you need the most from this scientific community? For example, what kind of development in QKD will push forward a lot on this industry?
Okay, that's a nice question. So what do the industry guy expect from this scientific community?
The first, I think, the scientist is our biggest supporter to guaranteeing the security. The protocol is secure or not. The thing is the very interesting first thing. And also, we need the scientist, scientific society, keeping finding new way, new protocols for the QKD or other quantum safe protocols to push this whole society provide better and better quantum safe services. I think it's a very, very important. It's our foundation.
So I guess an example is the IDQ has this COW protocol whose security or improved security was presented, I think it was on Monday, by a group from Singapore. So you have Singapore proving some improved security for the IDQ Swiss-based company. And this probably goes into the direction of what you're just asking, more generally, of course, more globally. Maybe some more comments on that question?
I see an important issue, and that's actually the community, because of tradition and all. Because of tradition and all that, has always focused on all-in solutions. Solution that is, for example, long distance, high rate, multiplexing, and all that, and this doesn't work. So actually, there should be an interaction here. We should first find out from an industrial point of view what is really needed, which things need to be optimized where, and when we know, then we can have questions to the scientific community how, for this specific case, for example, short distance or low Q rate, you can optimize other parameters, which is something which is not worked on presently. Yeah.
Okay, so we heard before that for the power grid we need 200 kilometers. That was one of the requirements. And indeed, you could imagine in different applications you need maybe shorter distance but higher rate. So I don't know. What is Alibaba's main request?
So I think this QKD community probably need to understand the customer need better. And QKD community basically the physicist, and physicists and for example engineers they different world and they understand things differently. I think if you know the customers need better, you can better serve. You have you have good understanding of physics. You can really use your technology to help the customers they really need, and just don't like you do your own things. Think that you need this. You need more communications, I think.
So Grégoire, you have real customers. So what are they requesting?
Well, so what has been said, and I think we've learned to listen to them and to apply, to make our system more practical. And so it's basically the same kind of requirements, if you can have longer distance, one fiber, etc. So nothing new. But here, maybe from the kind of startup spirit, what I'd like from the scientific community is more quantum stuff between QKD and quantum computing. More things that are truly quantum and cannot be done with classical physics, but where you can demonstrate something useful, but you don't have to build a full quantum computer in order to do something useful. Because I think that's also part of what will help us is to come out with more and more quantum applications. And in a sense, as a scientific community, if I wanted to be a bit provocative, I would say you failed in the past few years because all the ideas that we have now, they're kind of old in terms of applications. So can you find new applications that are less than 20 years away? And I want to be a bit provocative on this. And then the other thing, maybe not to the scientists in this room, but to the citizens, is to fight for information privacy. Because in the crypto field, we see this tension between security and privacy, and this thing that, if you want security, you cannot have privacy. And I talk not about security in the sense of QKD security, but security of our societies. And I think it's exactly the opposite. We can have both. We have to demand both.
Can I add some comment? A little bit?
Sure, sorry.
So I think we guys sitting here, so we can be the bridge, connect to the customer, the requirements, and the scientist. So we should do that. So we have to take the role. And also, I think it's very interesting. Recently, we find not only from the quantum computing, and also the classical computation show the potential. Their ability to solve more and more questions. So I think QKD is much more reasonable and very useful, even without quantum computing threat. I think maybe the traditional computation should go further. They have the potential.
Thank you very much. Very good question. We still have time for some more good questions. There's one again. Okay, let's start there, and then we come back to the front row.
Thank you. Yeah, my question to the panel, is primarily to Dr. Zhao from Quantum CTech, but please also the others if they have an answer or opinion about this. I've seen that there have been a lot of banks participating and partnering in your QKD network, and my question would be where you see their primary driver to join and participate in this network. Is it because of governmental regulations and requirements that put them in this situation? Is it because the banks have realized the need to protect their infrastructure more severely against threats, or even offer QKD and their keys as a service to their customers, or whether it was even the bank's customers that have requested and demanded the banks to act and improve the security?
I think it's quite an important question. From our concept, just like now you are using the mobile phone is quite different from them in the history, the old ones. But at that moment, Jobs showed the iPhone first. Nobody know what kind of requirements we meet this kind of device. I think in China we try to I have to say grow up with the customer together to create actually sometimes create requirements from or to find the requirements from their at their own to find the requirements to build the market. So not only from their own understanding, so we try to grow up together to find a service, to find what we can do together. So we have to do some innovation and stuff. Not only find customer, is to encourage or promote the customer.
Thank you very much. Maybe we come to the front row. Yes?
Okay. Nicola, I have a special maybe question for you. We know that there are a lot of activities on standardization with ETSI, but as you said before, maybe the survival question for the whole QKD society is a NIST decision. Why don't we put all together more efforts on bringing our ideas and pushing it to NIST?
Well, I mean, I think a lot of people tried. Okay, I'm not sure my answer will be politically correct, but since I'm in China, I don't need to be politically correct from a US perspective. And anyway, Charlie is sleeping. Um, I guess, you know, the US are spying the entire world. Why would they like to change? Some more questions? So we still have time for a couple of questions. Yes, there is one there. Good.
So, in their talk about quantum money was a very right question. Who is the object of protection? The government or the customers, the persons? And what do you think about it?
Yeah, so is the push going to come from governments or from private customers? Actually, we heard very different opinions, no? But I guess, again, has to do also with the political systems. You said it starts with private networks and private companies. You are more on the governmental side, I would say. Is that correct?
Really. I agree with that. We have to try a lot to find more and more individual customers and private customers, actually. So, yes, I not only from the government side, so also from the customer side, the individual users. So that is why we are working on how to find cheaper way to cut the cost, like you mentioned, how to do it. So I think we have a QKD device products. So if we only use for a private stuff, maybe more expensive, but how can we share it? So we push the QKD products like infrastructure, public infrastructure, and find a way to share the key generated by the system. Just like we maybe, for example, we make the key transferred by some car, something like that, to mobile phone, and we can use that and serve more and more individual persons. And I think this concept more close to the internet companies, how to get more and more users and services.
Yeah, thank you. Amchit, please.
I mean, I think that the situation is, of course, somewhere in the middle. Of course, I also believe in private initiative, but private, not of the private citizen, but rather big actors which have something that is valuable. And what is valuable? It's usually a critical infrastructure of any kind. If they need to protect their infrastructure because that is their asset. And if these people would be convinced, then we're almost there.
But can I disagree with you, Mamchil?
Yes. Very good.
With critical infrastructure, what you need is not confidentiality, but integrity, and so you can wait longer until there's a quantum computer to find a quantum safe solution. So in that sense, I think that even though I agree with you that assets, physical assets must be protected and critical infrastructure will be an application, I think that the case is less clear because you can wait longer.
Could be, of course, but of course, so QKD can very cheaply provide authenticity. And of course, this is the key to the infrastructure, yeah. So it's a kind of, you don't need secrecy, but you need authenticity, and authenticity comes on a very, very cheap level. So you need almost no key to provide information theoretically secure authenticity, yeah.
And by the way, Grégoire, of course, I agree with you. However, one of the first successes of QKD, of IDQ, was the voting system in Geneva, which is also not long-term security. It's more integrity again. And it has been a success, isn't it? Okay. Anyway, I don't see much, but yes, there's one question behind Norbert.
Hi, I'd like to discuss the business model of the QKD in a bigger picture. My question is, what kind of relationship between QKD and artificial intelligence? Why AI? What relationship between QKD and AI, or quantum safe and AI? The reason why I'm asking this question is because we know that Google launched a project. It's called the Google Brain in 2012. And the 2016, this project has a surprise test which is they try the following scenario. The two AI devices design their own cryptographic algorithms, and then they communicate each other. There is nothing to do with the human being. So you can imagine in the future, how can we secure our human beings' security?
So you're telling us that actually with AI, the future, maybe post-quantum cryptography, will be even less understandable to humans than quantum theory. You want to argue on that? Maybe there's another part of your question to which I can answer. So you were also asking what would be the relation between QKD and post-quantum cryptography. And there I think the answer is pretty easy. You have these national networks, like the one in China. And once you have this national network, QKD networks, not everybody needs to use it with the highest level of security. So not everyone will hook onto that network using QKD. Many people will just be happy using post-quantum because they don't have the same kind of long-term security. You know, main difference between QKD and this post-quantum cryptography is the time. QKD promises security over 100 years, so really very, very long time, in principle unlimited, while post-quantum will be secure until the next significant progress in either algorithmics or in physics. So it will only remain secure for maybe a few decades, we don't know exactly. You want to argue on that one, the relation between QKD, how could QKD and post-quantum cryptography benefit from each other and work together in good synergy?
Well, I think there's the obvious point of the authentication, where you could start the initial authentication could be done using a post-quantum scheme, and then once
because the security is only short-term until the first quantum key has been exchanged.
Exactly, short-term, and then you continue with symmetric keys. And we're trying actually this week in Paris, there's a meeting of the ETSI group on quantum safe cryptography. So it's not the QKD group, but the people from that look at quantum safe in general. And we're proposing there a work item on the topic of combining post-quantum crypto and QKD in this scenario. So I think that's an obvious thing that we need to try. And then the other thing is what you're saying is kind of the edge of the network, because also sometimes I've got some comments when I mention the fact that SK Telecom has invested, telecom operator, mobile operator. So what, you do QKD over mobile phones? Well, not yet. But the idea is you secure the core infrastructure with QKD, the physical infrastructure, but then the edge or the free space or the radio wave part can be done using post-quantum, or maybe also pre-shared secrets manually exchanged. And in a sense, you need maybe less security on this part because there's not a systemic impact if the core of the network is attacked. There's really a systemic impact. The full infrastructure falls. Whereas if someone can attack some public key on the edge, then you have to repeat this attack many and many times to have the same kind of impact.
I would just mention, so Masahide has here, Masahide has produced a kind of a very detailed use case where you use QKD and post-quantum cryptography for long-term security of data storage, which is something highly non-trivial. I mean, we have tried also in Europe, but at that time there was no financing. There are also highly non-trivial combinations of the two domains, and actually the field could only bring fruitful collaborations, provided, of course, some psychological problems, let's say, put to the side.
I totally agree with them. And I think I also very interested in the combination of the PQC and the QKD together. So, but yes, from some scopes, not only, for example, the authentication and the signature, and PQC maybe more convenient, I mean, than the QKD. But I also want to mention that the long-term security is not, I mean, it's very important to individual people. For example, your fingerprint, your bioinformation, this will with you for a long time. Yeah, I mean, I think so. That is why I think the QKD is also very important for individual people. So we can make it for everyone.
So who is going to ask the last question, the most important one, the one we're all going to remember? Masahide, you are actually the chair of this entire industry session, so I'm pleased to give you the word.
Okay, thank you for your great presentations and the questions and comments, but I'd like to know bad things or serious challenges for QKD, especially when you face the customers as pioneers of the QKD vendor. So let's be honest to tell a really serious challenge which we face to widen the QKD applications.
So which is the serious challenge that you are facing, the vendors, or maybe the customers? What is the most serious one?
I can try to answer. I think it's the fact that QKD is a physical layer technology, and it goes against one of the major IT trends, which is virtualization. And so it's hard to virtualize QKD, as you can imagine. And so it's hard to map it into a modern infrastructure, a typical IT infrastructure. And so from what I mentioned, that it's quite easy to do proof of concept, but then it's going to the next stage and say, okay, now there's this highly virtualized IT infrastructure. How do I map QKD on that in order to get some kind of security? So that would be my general answer to this question.
Yeah, please take your microphone.
Yeah, because I think it's very, very difficult to merge, them together. So we have some drawbacks we cannot, so we need scientists to find a way to build a real quantum internet. Can totally merge with the existing infrastructure.
Thank you. Maybe the very last words to one of the two customers, Sepri or Alibaba.
So for us is that you need to persuade a customer the value of the QKID to them, and it's not easy because security is that typically you don't see the value until you really have the problem, and I think the most difficult challenge for us is that your customer, you need to educate the customer the importance of the QKID. And the second thing is that if you provide them security without any cost, they would love to have it, but because it's high cost and they don't see the value right now, that's the most difficult part for us to provide customers.
So the most difficult part is actually also the main asset, the main value of QKD. It's long-term. Exactly. It's long-term security, which is of course on the positive side. But who cares about long-term? I will anyway be passed away or retired or whatever.
Exactly. That's a good point.
Maybe you want to say something also from a customer point of view on that, and then we go for coffee.
QKD provide for us not only a way for the deliver of quantum key technology, but also it can be combined with the traditional security key technology. And the traditional security key can be encrypted with QKD system and delivered by the QKD system. And so we can develop a quantum key serving cloud. And all the security can be delivered by the QKD system. And it can be used by information system and all the control devices and all the end users. It will be, I think it will, if it can achieve this, and it will be a great step.
Thank you very much. So to conclude this first session on the industry session, first part of the industry session, let me invite you to join me in thanking our 5 panelists. And now we have a little break, a coffee break, and then we'll meet again and continue. Thank you.